Welcome back to Chapter 4.3. The next thing we're going to discuss is naming and writing ionic formulas for metals that form more than one cation. Okay, this is different from what we've looked at previously because our group 1, 2, and 3 metals always form a +1, +2, or +3 ionic charge. However, for transition metals, except zinc, cadmium, and silver, form 2 or more positive ions. So this means that copper could be represented as having a 2+ ionic charge, or it could have a +1 ionic charge. Okay, and the list can go on as you see here, and so it means that they vary. Okay, and so what we're going to have to do is we're going to have to determine, based upon what it's bonded with, what nonmetal it's bonded with, we're going to have to determine the ionic charge. Okay, but when we are naming transition metals, ionic compounds that include transition metals, we use a Roman numeral to identify the charge. Okay, this Roman numeral is not how many atoms are there, okay, are present. It is the ionic charge, so this number here. So if we have copper 2+, we put a 2 in Roman numerals outside of the name copper. Okay. We look down here, we've got lead 4+. So we put the charge in the Roman numeral here. So we have lead 4. Okay, same here. Chromium 6. We put chromium and then 6 for its ionic charge. Okay, so how can we find the charge? Okay, it's actually pretty simple because of the fact that we know that when a metal and a nonmetal combine, the total charge has to equal 0. Okay, and so what we do here, it's already written out here for you, but I'm going to actually go through and write it out slower here. Okay, if we look at our total charge for our compound, it's got to be 0. So what we're going to do is, right now, we don't know, so manganese. So the first thing, go back to this, you want to recognize what compound you're looking at. So we have manganese, so you want to go find it on the periodic table, and you're going to see it's a transition metal. Our transition metals are B, they're non-representative, and this is one of the reasons they're non-representative. It's because they can form variable charges. Okay, and so manganese is a transition metal, so we know we have a metal, and then we know fluorine is a non-metal. So the first thing we know is that we have an ionic compound. Okay. But we can't just name the ionic compound the way that we have done previously. We have to take note of and write out the Roman numeral indicating the charge or the ionic charge of our metal because it varies, and so we need to know which charge it has in the specific compound. So if we have manganese and we do not know the ionic charge because it could vary. Okay, it's not indicated by its group number. Okay, but we have 2, okay, can't forget, we have 2 fluorine atoms, so we have 2 F minus 1. Okay, the -1 comes from being in group 7, it needs to gain 1 electron to be like the nearest noble gas, and we have 2 of them. So we have a total -2 charge. Okay? So we know that X plus -2 must equal 0. Okay, and so we know that, well, metals have a positive charge, first of all. So the only way we can equal 0 is if our manganese has a +2 charge. So we know now that manganese is a 2+ charge, and we're going to represent this. It's going to go into our Roman numeral portion of the name. Okay, so when naming metals with variable charge, you first determine the charge of the cation from the anion. So that's what we just did. We determined that manganese had to have a 2+ charge in order for the total charge to equal 0, based upon the fact that we're bonded to a 2 fluorine atoms. Okay, then you name the cation by its element name, just like we've done previously, and then you put the charge in the Roman numeral in parentheses right after the name of the cation, which we know cation here is our metal. Okay. Cation just means positive charge. Okay. Anion means negative charge. And then we just name the anion and end with IDE, just like we have done previously before this. So we write the name of the cation first, and then the name of the anion second. So metal comes first, then the nonmetal. Okay, so we're going to go through and do one for practice. So we have FeCl2. So we have to first determine the charge of the cation. This is really the hardest part, okay, because everything else is kind of repetitive. So we don't know what our charge is here, but we know that chlorine is in group 7, so it has a -1 charge, and we know that we have to equal 0, and we know from our formula that we have 2 chlorine atoms with a -1 charge, and we need our charges to balance. We need it to equal 0. So we know that we're going to have an ionic charge of +2 on the iron in order for us to equal 0. Okay, then we're going to name the cation, so our metal is iron. Okay, and we're going to put the oxidation state is another term for ionic charge. Okay, we're going to put this charge. Okay, so remember, this doesn't indicate the number of atoms. It indicates the charge, the ionic charge. We're going to put it in Roman numerals in parentheses right after the name of the metal. And then you just name the nonmetal. So chlorine becomes chloride, just like we've done before. And then we put it together. So the iron 2, representing the ionic charge of the iron chloride. Okay, let's name the following compounds. Okay, so we have iron. Okay. First thing we notice, iron is a transition metal. We know we're going to have to use Roman numerals when we name. Okay, we have a metal and nonmetal, so we know that we have an ionic compound. Our nonmetal, we know, has a -2 charge because it is in group 6 and it needs 2 electrons to be like the nearest noble gas. Okay, and so if we look at our formula, we have 3 oxygen atoms. We know our total charge for the compound has to equal 0 in order for all of our atoms to be satisfied, all of them to be happy with the electrons in their octets. Okay, and so what are we going to have to, what's going to have to be the oxidation state or the ionic charge for iron? Okay, we can't forget here that we have 2 iron atoms given to us in the formula. So basically we're solving for x. So 2 times what number plus -6 will give us 0. So 2 times 3, so 2 times 3 plus -6 equals 0. 6 minus 6 equals 0. Okay, and so our Roman numeral is going to be 3. Okay. Oxygen becomes oxide. Okay, so we have to recognize first that we've got iron 3. Okay, this is where this comes in, whatever we're solving for there. And oxygen becomes oxide. And there is a space here. So you have a space between the metal and the nonmetal. Okay. Next we have SN and Cl. Okay, so if you didn't know, it's hard for me not to just call them by name, but you have to go to a periodic table and find, I will give you a periodic table that also has the names underneath the symbols. I don't expect you to know all the symbols and names at this point. Okay, so you have 10. So if we look at SN, in, that's going to be 10. Okay, and what we don't know is the oxidation state. And then we have chlorine, which we know becomes chloride. So basically, we're just coming up with the Roman numeral. And the reason we have to do this is because tin, lead, antimony, and bismuth, I don't know if we included that, but those are also group B, or they are considered to be non-representative elements. So tin, antimony, lead, and bismuth, you see that on the far right, kind of over from your transition metals, those are also considered to have variable oxidation states. Okay, so now we have to find the ionic charge. So we have chloride, and we have two of these. We're going to look at it like this. So we have a -2 charge. We know our total charge has to equal 0, and we're looking for X. And we only have 1, so we're given 1 in the formula. So 1 times which number would give us, -2 would give us 0. So if we plugged in a 2, -2 equals 0. So our Roman numeral must be 2. So I kind of did this out of order. You can first, solve for the charge if that's the way you want to go about it. I just like plugging in everything I know and then going to find what I'm looking for. But either way, it works just as well. So you want to find the Roman numeral, find the ionic charge, plug it in, and then be sure that you have your correct names and that you end in IDE.